Heat does not need flame. It can rise from water, fall from the sky, build inside your body. At first, you only feel discomfort. Then the system starts to fail. Nature looks calm, beautiful, silent, alive. But beneath that surface, there is force, pressure building, gas rising, ice cracking, wind sharpening. A lake can suffocate a valley. A tree can burn your skin. A storm can erase direction. This is Nature is Scary, the planet that does not care. Most people imagine heat as something visible. Fire, lava, a glowing surface. But heat does not need to glow. It does not need smoke. It does not need flame. It can sit in the air, press against skin, move through stone, rise from water, or collect inside a body that can no longer release it. That is what makes heat dangerous. It can feel ordinary at first. A warm afternoon, a dry trail, a quiet river steaming in the forest. Then the numbers start changing. Sweat stops cooling. Water evaporates faster. Breathing becomes work. Metal expands. Rock fractures. Air begins to move upward with force. Heat is not just temperature. It is energy moving through a system. And when that system is your body, there is very little room for error. The human body survives by holding a narrow range. Too cold, and chemistry slows. Too hot, and chemistry begins to fail. In extreme heat, the body tries to defend itself. Blood moves toward the skin. Sweat spreads across the surface. Evaporation carries heat away. But that defense has limits. Humidity slows evaporation. Direct sun adds more energy. Hard work makes more internal heat. And dehydration removes the body's cooling fluid. At first, the warning signs can look small. Weakness, dizziness, nausea, a fast pulse, confusion. Then, heat stops being outside the body. It becomes the body's internal condition. Heat exhaustion can progress. Heat stroke can become a medical emergency. The body is no longer controlling temperature. Temperature is controlling the body. This is why extreme heat kills quietly. No impact, no wound, no visible attack. Only a system losing its ability to cool itself. A heat wave is not just a hot day repeated. It is a pattern that holds. A mass of hot air settling over a region, clouds thinning, ground absorbing energy, cities storing it in concrete, asphalt, glass, and steel. Day after day, the surface heats. Night after night, it fails to cool enough. The danger compounds. Hospitals see more stress. Power grids strain. Water demand rises. The body enters each morning with less recovery than the day before. That is why heat waves are so deceptive. They do not arrive like a wall of water. They arrive like normal weather that refuses to leave. And when humidity is high, the air begins to feel less like air and more like a wet barrier wrapped around the skin. The sky does not fall. The ground does not open. But for anyone trapped inside the heat, the whole environment becomes pressure. Still, heat does not behave the same everywhere. In some places, the same land that burns by day can turn cold after sunset. Deserts are often imagined as only hot. But many deserts are systems of extremes. During the day, Sunlight pours into dry ground. There is little moisture to absorb the energy, little vegetation to soften it, little cloud cover to interrupt it. The surface heats fast. Then night arrives, slowly, and the same dry air that allowed rapid heating allows rapid cooling. Heat radiates away. The ground loses energy. The air near the surface cools, and a landscape that punished the body by day can threaten it in a different way after dark. This is not contradiction. It is the same system changing direction. Heat moves out, cold moves in, and survival depends on timing. But some heat does not come from the sun at all. Some rises from the planet itself, through water that should be safe to touch. In parts of the world, water itself can carry the threat. A river may look alive, moving, clear, natural, but if geothermal heat enters that water, the surface can become a trap. The boiling river of the Peruvian Amazon is one of the most famous examples. A river feeded by geological processes, so hot in places that contact can injure or kill small animals. It is not magic. It is not fire hidden under the current. It is heat transferred through rock, water, and fractured ground. Steam becomes the warning, but steam can be easy to misread in a rainforest. Mist belongs there. Humidity belongs there. Water sounds safe there. That is what makes thermal water unsettling. It keeps the shape of something familiar while changing the rules of contact. And rivers are only one expression. Elsewhere, heat rises directly through volcanic ground. Volcanic heat does not always arrive as an eruption. Sometimes it appears as steam from the ground, a fumarole, a mud pot, a hot spring, a vent breathing from below. The surface may look fragile, crusted, pale, almost dry, but beneath it, water and gas can be near boiling or hotter under pressure. In hydrothermal areas, thin ground can hide scalding water. Steam can burn. Acidic water can damage skin. Gas can collect in low places. And the line between solid ground and thermal hazard can be hard to read. This is heat as geology. Not a flame, not a furnace. A transfer of energy from inside Earth into the world above it. The danger is that the planet does not label the surface for you. A pale crust can look stable. A pool can look calm. A vent can look small. But heat underground is not still. It moves through cracks, water, gas, and pressure. And above ground, when heat meets fuel and wind, it can begin building weather of its own. When heat becomes intense enough, it does not only burn fuel, it starts moving air. Hot air rises. Cooler air rushes in below it. Winds strengthen. Flames lean. Smoke lifts into columns. In extreme fires, the system can organize itself. A firestorm can generate its own wind field. A fire whirl can spin upward from superheated, unstable air. Sometimes people call it a fire tornado because it looks like the atmosphere has been twisted by flame. But the mechanism is physical. Heat, rotation, vorticity, rising air. The fire begins feeding the motion that feeds the fire. That feedback is what makes it terrifying. The danger is not just flame moving across land. It is air becoming part of the engine. And fire is not the only place where heat builds an entire ecosystem. Far below the ocean, there are vents hotter than boiling water, surrounded by life. At the bottom of the ocean, heat escapes through cracks in the crust. Seawater seeps downward. it meets hot rock. It becomes superheated. Then it rises back into near-freezing darkness. Hydrothermal vents can release water hotter than anything you would expect liquid water to survive. Under deep pressure, it does not boil the way it would at the surface. When that hot, mineral-rich fluid meets cold seawater, chemistry erupts. Black chimneys form. White chimneys form. Minerals fall out of solution. A landscape grows from heat. And around it, life gathers, not from sunlight, from chemistry, from bacteria that can build food using energy released from the earth. This is the strange truth about heat. It can destroy tissue. It can fracture rock. It can feed fire. It can also support ecosystems in total darkness. Heat does not care which outcome we prefer. It only moves, and the body must move with it or fail. Every heat system in this episode follows the same rule. Energy moves through air, through water, through stone, through fire, through the human body. Sometimes it moves slowly, building through days of heat. Sometimes it rises from the ground. Sometimes it spins upward inside a fire. Sometimes it escapes from vents in the deep ocean. But when heat reaches living tissue, the question becomes immediate. Can the body lose heat fast enough? If it can, survival continues. If it cannot, the system begins to break. That is why heat is one of nature's quietest threats. It does not always strike. It surrounds. It enters through skin, through breath, through work, through time. And by the time it feels impossible, the body may already be behind. Heat does not need flame. It only needs enough time to rewrite the body. Storms are more than weather. They are pressure, electricity, wind moving with destructive force, and sometimes the atmosphere changes before the human mind can react. What we have seen is not nature turning evil, it is nature operating normally. Gas rises, water moves, storms form, and when the conditions align, life gets caught in the system. Because the planet does not choose victims, it only follows physics.